Okay, let's look at this another question on this thing, a scale. Now, we have the scale here. 7:8. This is the smaller one. Okay, now, if the radius of the smaller ball is 21, then which one is smaller, 7 or 8? Is 7, isn't it? So what it's saying is D is 21 cm. What will be the length or the radius of the larger one? So similarly, we cross multiply. So it's 21 times 8 divided by 7, cancel is 3. So what you end up is 24 cm. This will be the radius of larger ball. Okay. Now, let's look at the other one. It's talking about volume now. Okay. Trying to compare the volume of the larger versus the small one. Now, how would you use the scale? You see, the scale here is basically the linear length. Like, for example, you're talking about the radius. Radius, in this case, is the linear length. Okay? But this one is talking about volume. So how would you convert a scale which is regarding the linear length into volume? Okay, now before we go into this question, let's look at the basic one. Now, let's say 1 cm is to 10 meter. Okay, now this is a scale that regarding linear length. 1 cm represents 10 meter. Now, what about if I want to compare the area? So it's very straightforward. 1 cm now. So area will be cm squared. So what I'm going to do is I'm going to take 1 cm times 1 cm. If on the left is 1 cm times 1 cm, then on the right will be 10 meter times 10 meter. Okay, so here become 1 cm square is to 100 meter. 10 times 10 get 100. Meter times meter become meter square. Okay, what do you see? Now I have converted the scale from a linear length, which is 1 cm to 10 cm, to a area scale. In this area scale, 1 cm on the drawing, or 1 cm on the prototype, okay? 1 cm on the model, 1 cm square on the model, in terms of area, actually represent 100 meters square on the actual object. Okay, let me repeat again. From a linear scale, 1 cm represent 10 meter. I have converted to 1 cm square represent 100 meters square. Okay, so in other words, from a linear scale, I have changed to a area scale. And on this area scale, 1 cm square on the model or on the drawing actually represent 100 meters square on the actual object. Okay, now let's proceed further to find the volume scale. Okay, now how do you get volume scale? You take the linear scale 1 cm times 1 cm times 1 cm. On this side will be 10 meter time 10 meter time 10 meter. Okay, now this will end up as 1 cm cube. This will become 1000 meter cube. Now let's interpret this result. Now this is 1 cm cube. In other words, on the model, if the volume is 1 cm cube, will represent 1000 meter cube in terms of volume for the actual. Okay, on the model, 1 cm cube of the model represent 1000 meter cube of the actual object. So this is how you convert from a linear scale to a scale that is comparing the area. Okay, then you go into the volume scale. Okay, now let's hopefully you understand this. Now let's go and look at this second part of this question. Now we have 7:8. Okay, this is a linear scale. Now let's put in, we are talking about cm, volume is cm. So let's put cm is to 8 cm. This is a linear scale. The question asks for a volume scale, so let's convert into volume scale. Volume scale is taking 7 cm times 7 cm times 7 cm is to 8 cm times 8 cm times 8 cm. So this will give you, or you can just give it 7 to the power 3 cm cube represent 8 to the power 3 cm cube. So this is a volume scale. Okay, now let's look at the question. It said that the volume of the larger bore is 1024 cm cube. The larger one, as you can see, this ratio of 8 here. So I'm going to put it over here since the larger bore, 1024 cm cube. So to get the volume of the smaller one, we're going to cross multiply and divide by 8 to the power 3. So this multiplied by this, 7 cube times 1024 divided by 8 to the power 3. What you get is cm cube. So I'm going to do this, simplify this above here. 7 times 7 times 7 times 1024 over 8 times 8 times 8 cm cube. Okay, now let's simplify this. 8 1 16 1 2 8 yes 1 2 8 Simplify this again. 8, 1, 648. So this 16. Simplify this further. You got a 2. Okay? Now, so 7 times 7 times 7 times 2. 7 times 7 is 49. 7 times 2 is 14. Okay, now let's go and multiply this. 49, 14. This 36, this 196. You put a 9 here. You put a 4 here. So 6, 8, 6. So equal to, final answer is 6, 8, 6 cm cube. Okay, so this is quite important in the sense teacher have shown you how to convert a linear scale to the area scale or to the volume scale. Okay, once you have the volume scale, then whatever given in terms of volume, depending whether it's on the larger side or the smaller side. In this case, it's on the larger side, so we're going to put it on 01024. So to get the volume of the smaller ball, you just cross multiply and divide by 8 here, and you get 686 cm cube. Okay, so that's it. Let's check any mistakes. 4, okay, no mistake in our multiplication. That's it. Hopefully you can understand. I see you then.